Hi, today we are going to discuss about limits. Okay, limits forms the basis of all of calculus. Everything is basically built around limits. So it's a very critical topic to understand. And the whole centerpiece of limits is this thing that we call 0 by 0. And the fact that we can't calculate it easily. Okay, we call 0 by 0 indeterminate, you might have heard of it. Before we get down to 0 by 0, there is one more character that we need to get introduced to, and that is 1 by 0. So 1 by 0 is not indeterminate. It's a weird number, but 1 by 0 is definitely not indeterminate. On the other hand, this thing 0 by 0 happens to be indeterminate. And let us, before we understand what that means, let us think about it. One is to, of course, simply say division by 0 is not defined. Okay, you might have heard this. Let us see why is it not defined. Let's think about it. What is 4 by 2? If I ask you what is 4 by 2, what do you mean? What is the answer?
Just
2. Okay. Why is this 2? Why are you so sure? We'll come to that in a minute. But let us go to one more. Suppose I say 9 or let us say 12 by 3. What is 12 by 3? 4. What is the meaning of saying 12 by 3 is 4 or 4 by 2 is 2? What do we mean by that? But what does it mean? It means when I multiply these two, 2 into 2, it gives me 4. 3 into 4 gives me 12. So why do you know that 12 by 3 is 4? Because 3 into 4 is 12. So 12 by 3 is 4. In fact, that is almost like a definition for division. But if that is true, then let us consider the two numbers 0 by 0. I want to find out what this is. And I also want to find out what is 1 by 0. So suppose I say, I am going to claim 0 by 0 is 5. Why? Because 0 into 5 is 0. 5 is not the only number which will satisfy this. Okay, so let us think on the other hand. Suppose instead of saying 2 into 2, suppose I try 2 into 7, it will not be equal to 4. It's 14, it's not equal to 4. If I try 2 into 25, that is 50, it is not equal to 4. If I look for 2 into 3, that is not equal to 4. 2 into 0.2, not equal to 4. Not equal to, not equal to, not equal to, not equal to, not equal to. But 2 into 2 alone is equal to 4. Therefore, this is uniquely defined. Let us look at this. 3 into 4 is 12. 3 into something else, if you try anything else other than 4, if you try 6, you get 18, which is not equal to 12. 3 into 7, not equal to 12. The only thing that will satisfy this box is 4. Therefore, we say 12 by 3 is 4, unique. Whereas with 0, if I tried 0 into 7, that's also 0. So I can fit 7 into this box. I can say 0 into 15, 0. In fact, 0 into any number, negative number, positive number, 0 into 0 is also 0. So any number will fit in. So the real problem is, if I restate this idea, the point is we are saying 4 by 2 is 2 and 4 by 2 is not 3, 4 by 2 is not 7, 4 by 2 is not minus 18. It is not any of this, it is only this. Is 4 by 2 2? Yes. Is 4 by 2 3? No. Is 4 by 2 7? No, no, no. We can say this very clearly. We end up with one number. 12 by 3 is 4. Yes. 12 by 3 is not equal to 5. We know that because 3 into 5 is not equal to 12. So that means if I try saying anything else, you will end up saying no, 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 no. But there is one yes answer. There is one answer to which it is yes and every other answer which is no. But with 0, if I ask you is 0 by 0 5, you can say yes. But the problem is, if I say is it equal to 6, you can say again yes. Because 0 into 6 is 0. And if I ask you is it 21.3, it is again a yes. In fact, any number you choose, it is a yes, including 0. 0 into 0, yes. Minus 1, yes. Too many yeses. The problem is not that you don't have an answer. The problem is we have too many answers. We cannot determine which of these answers is correct. So we say it is indeterminate because I couldn't find which of them is correct. All of them are okay. Everything is maybe. Is 0 by 0 5? The answer is not no. The answer is not yes. The answer is maybe. Whereas 4 by 2, is it equal to 3? No. It is not a maybe. It is a no. It's very clearly no. 4 by 2 is 2? Yes. 12 by 3 is 4? Yes. 12 by 3 is 5? No. This is maybe, because there are too many possibilities. What happens with 1 by 0? Let us think about 1 by 0. So we call this fellow indeterminate, because you can't determine which of the answers is correct. Too many answers. The problem is too many answers. Here the problem is, there is no problem because it's one unique answer. One unique answer for all of these. Whereas with 1 by 0, let us think about 1 by 0. If I ask, is 1 by 0 equal to 7? I can ask the question, right? That means 0 into 7 must be 1, is it? No. No, it is 0. So this is not equal to 1. So 7 is not a good answer. Okay. Is 1 by 0 equal to 12? No, because 0 into 12 is not equal to 1. So if you try 1 by 0, is it equal to 7? You are going to say no. Is it equal to 12? You are going to say no. Is it equal to minus 13.8? No. It's equal to something else. Let's try 0, 0 and 0. No. That means I never managed to find even one answer. You see, this is different from that. Everything maybe. Everything no. But you must need one thing which you say yes to, right? There is no yes. So we write this as a different, this is a different quantity, this is not the same type as that. We call this undefined. Why do we call this undefined? Because I couldn't find even one number which satisfies. Here I found too many numbers that satisfy. There I found one number that satisfies and only one number, no other number satisfies. I hope the difference is clear. It turns out that this number, it's an undefined number, but it is good, better than this. Why is it better than this? Because we can think of this as a number which does not fit into the number line. If I say here is 0, 1, 2, minus 1, minus 2 and so on. Something which is not on the number line is so far away from the number line, really, really far away, we call that number infinity. And to be a little bit more careful, generally we'll put a plus or minus infinity, where we assume infinity lies somewhere far away. Now, these are more precise definitions, or require more precise definitions. And if I go further on this side, we'll call it minus infinity. So 1 by 0 is not indeterminate. It's actually quite determinate. You can find it, except that it is not any of the numbers that you know. So you can think of it as a new kind of number which does not belong to the current set of numbers. So infinity technically is not a number, because no number will satisfy. So what we do is we extend this real number system and we add these two extra endpoints, technically not really a point, it's a whole set of possibilities, very large, larger than everything that you know, and then we call it an extended real number system. In that extended real number system, 1 by 0 can be thought of as a new kind of number, infinity. It doesn't satisfy many of the properties of the earlier numbers. It's not one of the real numbers, it is an extended real number if you want. Okay, so, but this is definitely not indeterminate. The job is not to say which of this is correct. You can say none of this is correct, right? Because none of them satisfy. With 0 by 0, the real problem is I don't know which one to select because all of them seem to satisfy. And in calculus and particularly limits, our job is to give this a meaning. It has so many answers. which of these answers is the correct answer? That is the kind of question we are going to face. And a whole subject is devoted to this one single idea, 0 by 0. Why is it even devoted to this idea? Let us think about some practical value for it. 1 by 0 I will come back to, but what I want you to understand is 1 by 0 is a very easy thing to understand compared to 0 by 0. So we will use this, I will come back to it in a minute later and talk about what 1 by 0 is. But that is not our focus. The focus for calculus is really this. Let us now try and understand why is this thing even going to come up in so many places. See, we are going to spend a whole course trying to understand how to calculate this. But why should we waste time calculating this? There are so many things to calculate. Because this happens to come in many places. Okay, where? Let us think. Now, if an object is moving with some velocity, okay, like particularly in physics, for example, if something is moving, now it may not be moving with constant velocity, so it's going to keep changing, right? Now, if the object had a displacement, and I call this displacement S, okay, S divided by the time, what does that give us? That gives us velocity if it was constant. Actually, what it gives us is average velocity. Okay, now, but average velocity is not good enough because your speedometer is actually showing you instantaneous speed. Okay, so we want instantaneous velocity, we want instantaneous acceleration. Okay, now if you want instantaneous velocity, what do we mean by instantaneous velocity? That means make the time interval really small. But if you make the time interval really small, how much have you traveled? In 0 seconds, how much will you travel? 0. So the displacement is 0, time is 0. And this, it gives me the instantaneous velocity. But this is weird. This is instantaneous velocity. I don't know how to find 0 by 0. That's what we just decided, right? But instantaneous velocity is 0 distance by 0 time. But what is this 0 by 0? That is the velocity of this particle at this instant. Because after a little while, it has had an average velocity. Like if I drop a ball, now the ball falls down, right, as it keeps moving. If I calculate this distance and divide by the time, that gives me the average velocity. But in the beginning, you know that when I drop it, its velocity was 0. At the end, maybe its velocity was 10 meters per second. What do I mean by saying 10 meters per second? That is instantaneous velocity. Average velocity turns out probably to be 5. So if I look at the velocity here, every point the velocity is different. How do I know what is this velocity? Well, what we do is just a little bit before. What is a little bit before? How little? That will give me the average velocity. So if I say, let us make this little thing very small, we usually call it delta t, a small time. In that small time, it would have had a small displacement, delta x. And we say that displacement by this time is that velocity. But actually, we should then, this is still what? Average velocity. Now, how do I find instantaneous velocity? By making this really small, making the delta t 0. But if delta t becomes 0, delta x becomes 0. If both become 0, it becomes 0 by 0. But we still manage to find out what is this fellow when this becomes 0 and that becomes 0, and we use a special way to write it. We call it limit delta t becomes 0. It turns out that this is 0 by 0, but you can still find the value. And that's exactly what we are going to learn how to do. And we call this value v. It is not any value, because often you say that this object is moving at 10 meters per second. Now, instantaneous value. How did we find it? By doing a 0 by 0. Okay, and this is one of the places where 0 by 0 is useful. Now you have heard about tangent of a circle. What is tangent of a circle?
It touches exactly the surface of the circle.
It just touches at one point, right? But actually if I draw a circle, what is the tangent? Tangent is something which is like a secant, except that both the points are the same. So if I took this point and that point, this would be the secant. If I took this point and this point, that would be the secant, right? And as I make this thing approach this, we say as this approaches that. So we usually use the word tend to or tends to. Okay, as this is, let's call this A and this is B. B tends to A, and mathematicians hate writing words. So then we say, okay, B tends to A. So what is that symbol? Tends to, gets closer to A. This is delta t gets closer to 0. That means you make this time interval really small. Okay, so as I make this get closer and closer, that means B becomes that both these points are the same point. But if I ask you, draw the unique line at this point, we don't know how to draw. Because with this point, you can draw so many different lines. But if this point is slowly tending there, then I had this line, then I had that line, then I had that line, and then at this place, this is the line. Right? So all these lines tend to that line. So when you're saying that I have so many secants, it tends to become the tangent. We have been using the idea of limits a lot. Okay, now is there a 0 by 0 there? Actually there is, because if I try to do the same for a function, so let us draw a function. Usually you draw functions as a graph, right? Y as a function of x. Now many times I want the slope of this graph at that point. What is slope? For a line, what is the slope? Yeah, that is if you already know a little bit of calculus. Otherwise, what is slope? This by that. For a line, slope, we usually call the slope m, is the change in y by the change in x. But the great advantage of a straight line is if I did this much change in y and this much change in x, or I did this much change in x and that much change in y, this by that is equal to this by this, because it is a straight line, similar triangles, right? So therefore, if I call this y2 and this is x1, y1, x2, y2, x3, y3, they are all in the same line, straight line. What is this difference? y2 minus y1. What is this? x2 minus x1. And what about that? x3 minus x1. And this is y3 minus y1. And slope, what is slope defined as? Rise by run. Okay, increase this way by increase that way. Actually the same as delta x by delta t, we have delta y by delta x. So what is this? y2 minus y1 by x2 minus x1, and that should not be called slope, it should be called average slope. It is okay here because it's a straight line. So whether I did y3 minus y1 by x3 minus x1, or I did y2 minus y1 by x2 minus x1, I get the same number. It is like saying constant velocity, this is constant slope. It's a straight line. But why should every curve be a constant slope? Obviously no, right? Most lines are not constant slope. So if I started here and I try to find the slope from this place to that place, what will the slope look like? This by this. But if I did it from here to there, the slope is different, no? You can see that that line, the slope is that. I'm finding the slope of that line. Whereas if I took this, I'm finding the slope of this line. Do you think these two lines have the same slope? No. And if I make this point get closer, I will get a different line. But can you see that as I start approaching it, the lines get almost the same as each other. Let me draw it a little better and show you. Okay, instead of doing this graph, let's take a different graph. So let us say I took this graph. I want to find the slope here. The actual slope there. The actual slope is going to look like that. But actually what are we going to do? First we are going to find the slope of this line. That is easy. This by this. So this line has a slope. But if I make, so let's call this A and let's call that B. Exactly what we did there. Suppose I make B come here. So now B is tending towards A. Now this was line 1. So I'll call that slope 1. And what about line 2? This is B1. This is B2. What is this line? Is this slope the same as that slope?
No.
So which is bigger?
M1 is greater.
M1 is bigger. So I'll call this slope M2. Now if I make this B2 get a little closer, B3, this is going to be the line. you can see that M3 is that slope. As I keep going closer and closer, the final thing is going to be a slope that is going to look like this. And we call this line the tangent at that point, exactly like we did for circles. Okay, now this line has a slope. Now that slope, I'm going to call it M. So what is that slope? This slope, then this slope, this slope. The values of all these slopes converge or become closer and closer to M. But if you want to calculate that M, how do you calculate M1, M2, M3? Delta Y by delta X, change in X, change in Y. So what is that slope? Delta Y by delta X. Now the point is, as B1 starts, B1, B2, B3, it gets closer and closer. What is going to happen? B gets closer to A. When B gets very, very, very close to A, we say that is the idea of limit. So limit B gets really close to A. What happens to this line? This line, which was a secant, has become this, has become this, has become a tangent. And that line would have a slope. So that is actually the value of M1, M2, M3, M4 will all basically converge to a small value called M. Is the value reducing in this case? M1 is bigger than M2, then M3. In this particular case, M will be the value which is actually smallest of all the lot, but need not be in every case. Sometimes it can go back and forth. But we say that this is M. But if you think about the fact that when it gets really close, what is delta X? 0. What is delta Y? 0. 0 by 0. Again we got back to 0 by 0, which we cannot calculate. Look at this. So many different things in mathematics and physics seem to require 0 by 0. The sad part is we can't calculate it easily. Right? So that's why we need to study how to calculate 0 by 0. And that is the basic idea of limits. Because once you know how to calculate this, you will know how to calculate this. You will know how to calculate velocity, you will know how to calculate acceleration, you will know how to calculate lots and lots of things. But also, the reason we also study this is because it's a lot of fun. Okay? So this is a new kind of item that we need to calculate. A new kind of quantity, 0 by 0. So we are going to spend a lot of effort to understand what this really means, why is it causing a problem, and then we will also learn how to actually avoid that problem. And if you avoid the problem, you can actually find out what the value is. But in all practical situations, if you notice one thing which I'll come back to again later, there is a relationship between these two zeros. In fact, that is what will allow us to find 0 by 0. If it's absolutely unrelated zeros, then it's going to be very difficult. But if they are related zeros, then we can. And that is in fact the big idea that Newton and Leibniz came up with when they started coming up with the idea of 0 by 0. Okay? They invented a whole new subject that we call calculus. So that is the focus of this course.